right, scientific notation. Every number can be written in scientific notation. Every number. Okay? And what scientific notation looks like. Okay? On your calculator, it might be like this: 2.342 whatever, and then you'll see that e to the fifth. And what that means is 2.342, if we want to round it to 3 decimal places, times 10 to the fifth power. And that's what scientific notation looks like. Okay? And so scientific notation contains two factors. Factors. That means something times something. Okay? The first factor is between between 1 and 10. It doesn't include 1, and it doesn't include 10. And the second factor is a power of 10. All right, so let me give you some examples of how we might write a number in scientific notation. And a lot of numbers are written in scientific notation. Sometimes they're too big for your calculator, so your calculator has to cut it down a little bit. All right, sometimes there's too many digits. Maybe we have, let's take a small one first, 3,425. And let's write that number in scientific notation. Okay? Well, I'm going to write that as a product of two factors. Okay, here's two factors. The first one has to be between 1 and 10, so I'm going to write that as 3.425. The second one times 10 to the third power. And what is 10 to the third power? 10 to the third power is not 30. It's 10 times, it's 10, no, it's not 10 times 3. It's 10 times 10 times 10, which is 1,000. And so if I multiply 3.425 times 1,000, I get 3,425.
So you have to figure out so how did you get the power?
And the way we got the power of 3 is, I'm putting the decimal place here, right?
Yeah.
And how many places did I move it? Well, I moved it 1, 2, 3 to the left. So that means I add 3. I'll do a couple more for you.
Now if it was a bigger one and we had 5 digits.
All right, let's take 5, 2, 1, 8, 7. And we want to write that in scientific notation. So this becomes 5.2187 times 10 to the fourth. And we started here and we go 1, 2, 3, 4.
Oh, so you just get the cat.
Okay? Mm-hmm.
So and it's always times 10.
Scientific notation, the first factor is between 1 and 10, and the second factor is a power of 10. That's what scientific notation is.
So we put the decimal right after the first digit, and then we
Correct.
count however many digits are after the decimal to get the power.
Yes. That's exactly right. So, let's take some examples here. Let's go the other way. Let's take a number like and let's write that number in scientific notation. All right? Well, the first factor has to be between 1 and 10. So, what am I going to write? 3.871 times 10. Now, times 10 to what power, Eric? Exactly. You know why it's negative? Because now I'm moving the decimal over this way. This is a real small number. So I'm moving the decimal 1, 2, 3, 4 places to the right. So that makes this a negative 4.
So if you move it to the left, it's a positive?
Yes. Mm-hmm. Okay? All right. Let's go the other way. Let's take a number like 13852 times 10 to the 7th. Okay? What number is that? I'm working backwards now, aren't I? Instead of going from the big number to scientific notation, now I'm going scientific notation. Now I want you to tell me, you have, oh, I'll get to you in a second though. 10 to the 7th power, is that a big number?
Yeah.
Yes. So which way am I going to move the decimal place?
7.
Which way do I move the decimal? To the right. Is this going to be a big number? That's why I asked that question.
Yes.
Yes, that's a bigger number. If you're moving this decimal to the left, it's going to give you a smaller number. So, what is it, Luke? 13,800,000. How many zeros? 3? Because I took the decimal that was here to begin with, and I moved it 1, 2, 3, 4, 5, 6, 7. And so this, we put commas after every 3. So we got a comma here, and Luke was right. It's 13,852,000. And if I take a number and go this way with it, so let's take I'm moving that decimal place. How many places? 8. Which way do I go, Sid? I go to the left. Okay. All right. Look, and you can check real easy. Start here and go 1, 2, 3, 4, 5, 6, 7, 8. So that's how you can sort of double check. Yeah, you know what? This is tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. 6,172, and I think that is trillions. Or maybe I think it's 100 billions. It's a small number.
Was that so?
I would imagine
A percentage of.
if they start splitting atoms, it's very small. Could be. All right.
Unless digit is like a number between 1 and 10. And when it's listed as a power, it'll be 0. Like if 3 digits are listed between 1 and 10 after the decimal, but the power is 7. The other 4 to get that 7 would be 0.
I don't know, you have to give an example on that.
Like for the
Mr.
1 point,
Why? Because I'm recording, I want to make sure we finish this lesson. Let's take a couple of examples now. Let's take 1.3 times 10 to the negative 5, and I want to take the and square it. Okay? And let's see what we get. Well, first of all, because I'm multiplying, I'm not adding inside, it is 1.3 squared times 10 to the what power?
negative 10.
Negative 10, very good. And now we go to our calculator, and I multiply 1.3 times 1.3, or square it, and what do I get?
1.69.
Is this first number between 1 and 10?
Yes.
Then I'm done. Okay? Let's take a problem like okay? And what do I do with the 4.5 and 1.5? Well, no, those we're going to divide. Okay? So when you divide those two, you know what you get? 3. Times 10 to what power?
A third. A third.
No, the third. And it's third. Thank you.
Negative 7.
Minus 7.
It is not negative 7.
7.
It is 7. Because what we do is we subtract exponents, and 5 minus a negative 2 is positive 7. And so this becomes 3 times 10 to the 7.
And that's good, that problem's okay.
Is the first factor between 1 and 10? Is the second factor a power of 10? Okay?
Now, what if the first factor wasn't between 1 and 10? Say it was.
Then you do scientific notation.
Scientific notation. The first has to be between 1 and 10. But we can't.
Okay. That's a good point. So let's do this. Let's take two numbers. Let's take two numbers in scientific notation. Let's take 4.2 times 10 to the 6th times 3.6 times 10 to the 4th. Okay? So let's take those two numbers. Now there's a couple different ways we can do that. All right, and I'm going to show you both ways. First of all, if I multiply 4.2 times 3.6, can you tell me what we get? 15.12 times 10 to what power? 10. Well, it's not exactly in scientific notation, is it? Okay. So what do I have to do? Yeah.
You just move the decimal over 1 and add on.
Perfect. I move this decimal over one place to the left, which is 1.512, and then I add one on here to make it 10 to the 11th. That's one way to do the problem. Another way to do the problem is to go to your calculator and 4.2 times times 10 raised to the 6th, close parentheses, open up another parenthesis, 3.6 times 10 to the 4th. Notice we have an E there, and I don't want you to write that on your paper, because what this means is 1.512 times 10 to the 11th. The E in your calculator doesn't mean anything.
It's 10. It means times.
It means times 10 to the 11th power.
Easier.
It's the same reason, that's a whole other thing. If it were up to me, I wouldn't let you guys have calculators and see that.
I'm kidding, Mr. Gilson.
I'm not kidding at all.
I said I'm kidding.
Oh, you are? Yes.
So let's say that, like, instead of having 15.12, it was like 0.1512 or something, and you would just leave the decimal point so it was above the 4, and you just like subtract 1 from the exponent.
If you're making this number bigger by 2, you make this one smaller by 2. If we took this number and made it smaller by 1, we make the exponent larger by 1. Yeah. Okay? All right. So, your homework. Really?